Hello, and welcome to another gentle journey on Sleepy Professor Stories. Tonight, you are invited into something that has been with you since your very first breath. Emotions are not interruptions. They are not flaws to correct or puzzles to solve. They are quiet companions, moving through you the way weather moves across a wide and patient sky. Sometimes they arrive like warm sunlight across your shoulders. Sometimes they gather like soft grey clouds. And sometimes they pass so subtly that you hardly notice the shift at all. As you listen, imagine your inner world as a landscape. Thoughts drift like slow rivers. Sensations rise like hills beneath mist. And emotions move across it all, shaping the light and color of each moment. Science tells us that these experiences are not abstract or imaginary. They are physical patterns, carried by signals that travel along nerves, guided by the brain, influenced by the steady rhythm of your heart and breath. They are ancient systems, older than language, older even than memory. Long before humans spoke or wrote, early nervous systems were already sensing change. A quickened pulse meant something in the environment had shifted. A surge of warmth meant safety or connection. These responses helped living beings survive, adapt, and stay connected to one another. What you feel today is part of that same lineage. Your emotions are not random. They are protective, responsive, deeply human. Tonight, we will gently explore where these feelings come from. We will wander through the brain's quiet activity, notice how the body participates in every mood, and discover how emotions bind people together in invisible but measurable ways. There is no test at the end of this journey. There is nothing you need to memorize or hold tightly. The information can move through you like a calm breeze through open curtains. If you find comfort in slow explorations like this, you are welcome to support the channel in any small way that feels natural. A simple like or subscription helps others discover a place where learning is unhurried and safe. But that choice can wait. Right now, there is nowhere else you need to be. Allow your breathing to soften. Notice the gentle rise and fall of your chest. Let your jaw unclench, your shoulders lower, your hands rest easily. There is nothing to analyze, nothing to fix. If sleep comes before we finish, that is perfectly fine. The science will continue quietly without effort from you. Emotions are often described as feelings in the heart, but they begin as patterns of activity deep within the brain. Certain regions constantly scan your surroundings and your internal state, asking simple questions. Is this safe? Is this meaningful? Is this familiar? These questions unfold without words. Electrical impulses move between networks, comparing what is happening now with what has happened before. In this gentle comparison, meaning is formed. At the same time, your body participates in the conversation. Tiny sensors monitor your heartbeat, your breathing, the tension in your muscles, even the temperature of your skin. This steady stream of information flows upward to the brain, where it is interpreted. Emotion is not just a thought layered on top of sensation. It is the interpretation of sensation itself. When your heart beats faster, the brain does not ignore it. It asks why. And in answering that question, a feeling begins to take shape. You might imagine the brain as a quiet conductor, guiding an orchestra of signals. Memory plays a soft string section. Sensation offers a low hum of percussion. Expectation contributes a faint melody. Together, They create what you recognize as joy, sadness, fear, or calm. No single instrument works alone. Emotion is a collaboration. Now, what makes this especially beautiful is that your brain is always predicting. It does not wait passively for the world to explain itself. It gently anticipates what might happen next, based on everything you have experienced before. When reality matches the prediction, the body relaxes. When it surprises you, emotion shifts. This constant dance between expectation and experience colors each moment of your day. Even now, as you lie here listening, subtle predictions are forming. The rhythm of my voice becomes familiar. The quiet in the room settles into something expected. Your nervous system begins to understand that this is a safe space. That understanding is not philosophical. It is biological. Muscles soften because signals of safety are traveling through your body. Emotions, then, are not disturbances to be silenced. They are adjustments, fine-tuning your awareness to the world around you. They help you move toward warmth and away from harm. They guide connection. They shape memory. Experiences that carry emotional weight are stored more deeply, woven into the fabric of who you are. This is why certain moments feel vivid even years later. Emotion gently marks them as meaningful. And yet, despite their power, emotions are temporary. Research shows that even intense feelings rise and fall in waves, often lasting only minutes, unless we continue feeding them with thought. They crest, they soften, they pass. Like weather patterns, they are dynamic rather than fixed. Remembering this can bring a quiet sense of spaciousness. Whatever you feel, it is moving. As we continue, we will look more closely at how the brain constructs these inner climates from simple ingredients. We will notice the pathways that allow a sensation in the chest to become a story in the mind. And we will explore how these private experiences quietly connect you to every other human being who has ever felt a quickened heartbeat or a gentle swell of warmth. For now, simply rest with the understanding that emotions are not mysteries hidden in darkness. They are natural processes unfolding in light, shaped by biology and experience alike. And in the next part of our journey, we will wander deeper into the brain itself to see how these patterns are assembled moment by moment, and like soft brushstrokes painting the sky from within. Before there were words for joy or sorrow, before stories were told around fires, before memories stretched backward into personal history, there were signals, soft, electrical flickers in tiny living bodies, responding to light, temperature, touch. If you imagine the earliest forms of life drifting in ancient oceans, you might picture something simple, almost transparent. Yet even those early organisms carried within them a basic ability to sense change. A shift in light meant movement above. A chemical trace in the water meant food nearby or danger close. These were not emotions as you know them, but they were the beginning of feeling. The nervous system, in its earliest form, evolved not to create poetry, but to protect life. Cells developed the ability to communicate rapidly through electrical impulses. One part of a small body could alert another part that something important was happening. This communication allowed movement toward nourishment and away from harm. Over millions of years, these signaling systems became more coordinated, more complex. What began as a simple reflex gradually formed the foundation for what you now recognize as emotion. If you rest for a moment and notice your own heartbeat, you are sensing the echo of that ancient design. So your heart speeds up when something demands attention. It slows when safety returns. This rhythm is not accidental. It is guided by networks in your brainstem and deeper regions that evolved long before human language. These areas constantly monitor your internal state, adjusting breath, pulse, and muscle tone. Feeling, at its root, is the body's way of staying alive. As animals grew more complex, their nervous systems developed specialized clusters of cells capable of integrating information from many senses at once. Instead of reacting only to touch or light, they could combine sight, sound, and internal signals into a coordinated response. This integration allowed for something new, a unified experience of the environment. The body did not just move automatically. It assessed, it prepared, it responded with patterns that were flexible rather than fixed. You can think of early emotion as a bridge between sensation and action. When a creature detected threat, chemical messengers surged through its body, increasing energy availability, sharpening focus. When it encountered safety or nourishment, different messengers promoted rest and restoration. These chemical patterns laid the groundwork for what would later become fear, contentment, attraction. The language was not yet there, but the biological script was already written. Inside your own brain, and structures that handle these ancient processes still operate quietly. Regions deep beneath the surface help evaluate whether something is safe or uncertain. They influence how strongly your heart beats and how quickly your breathing changes. These reactions happen faster than conscious thought. You often feel before you can explain why. This is not weakness or irrationality. It is efficiency, shaped by countless generations who survived by responding quickly. Emotions, then, are layered. At the base lies physiology, heart rate, hormones, muscle tension. Above that lies interpretation, the brain's attempt to make sense of these bodily changes. When your pulse quickens, your mind searches for meaning. Is this excitement? Is it worry? The interpretation depends on context, memory, expectation. The same bodily sensation can become different feelings depending on the story your brain assembles around it. It may comfort you to know that this process is ongoing and dynamic. Your brain does not store a fixed set of emotions like objects in a cabinet. Instead, it constructs them from basic ingredients each time they arise. Sensation flows upward from the body. Memory offers reference points. Attention selects what matters. Together, they create the experience you name as anger, joy, sadness, or calm. And just as they are constructed, they can also dissolve when conditions shift. If you imagine standing at the edge of a forest at dusk, your senses become slightly heightened. Shadows deepen. Sounds feel more significant. Your body prepares gently for uncertainty. Now imagine the same forest at midday, sunlight filtering through leaves. The landscape is unchanged, but your internal state differs. This shift illustrates how emotion is not only about the external world. It is about how your nervous system predicts and prepares for what might come next. Prediction is one of the brain's most remarkable abilities. Rather than waiting passively for events, it continuously anticipates them. Based on past experiences, it generates expectations about what sensations will occur. When those expectations match reality, you feel steady, When they do not, your body adjusts. This constant forecasting helps conserve energy and maintain balance. It is a quiet, invisible process, but it shapes every emotional moment. Balance is central to survival. Your body strives to maintain internal stability, keeping temperature, blood sugar, and hydration within healthy ranges. Emotions contribute to this regulation. They motivate behavior that restores equilibrium. Hunger encourages you to seek food. Loneliness nudges you toward connection. Fear moves you away from danger. In this way, emotions are not abstract moods floating in the mind. They are tools for maintaining life. Across evolutionary time, social living introduced new layers to emotional experience. Early mammals relied on caregivers for survival. Attachment behaviors evolved to keep infants close to protection. Warmth, touch, and vocal sounds became signals of safety. Hormones associated with bonding strengthened these connections. The comfort you feel in the presence of someone kind is rooted in these ancient systems. It is biology expressing itself as belonging. Even now, your nervous system responds to tone of voice and facial expression before you consciously analyze them. Subtle cues are processed rapidly into shaping your internal state. This sensitivity once allowed small groups to coordinate and cooperate. It fostered empathy and shared attention. Emotion became not only a survival mechanism for individuals, but a binding force for communities. As you listen, there is nothing you need to do with this knowledge. You do not need to trace every feeling back to its origin. Simply notice that within you flows a system refined across vast stretches of time. Every flutter of anticipation, every gentle wave of contentment carries the imprint of ancient oceans and early forests. Your emotions are not random storms. They are patterned currents designed to guide and protect. When you experience sadness, your energy may slow, encouraging reflection and rest. When you feel joy, your body may open, inviting connection and exploration. These shifts are purposeful. They shape attention, memory, and behavior in subtle ways. They are adaptive responses and woven into the architecture of your brain and body. And yet, despite their biological roots, emotions remain fluid. They rise and fall. They interact. They blend into one another like colors in a sunset sky. Recognizing their origins can soften self-judgment. What you feel is not a personal flaw. It is an ancient language spoken by cells and circuits working together. As we move forward, we will gently explore how the brain assembles these signals into the rich inner weather you recognize as your emotional life. We will step deeper into the quiet structures that interpret sensation and construct meaning, discovering how prediction, memory, and perception collaborate to paint the landscape of feeling. Inside the soft folds of your brain, there is no single room labeled joy, no small drawer marked fear. Instead, there is movement, a living landscape of cells exchanging electrical signals, shaping experience in real time. If you could shrink yourself down and wander through this landscape, you would not find emotions stored like books on a shelf. You would find activity, patterns forming and dissolving, like clouds gathering and drifting across an open sky. Your brain is constantly receiving information from your body. Tiny sensors in your heart, lungs, stomach, and muscles send quiet updates upward. They report on pulse, on breath, tension, warmth. These signals travel along nerve pathways and arrive deep within the brain, where they are interpreted. Before you ever name a feeling, your brain has already begun assembling it from these internal messages. One region, nestled beneath the outer layers, plays a central role in detecting what is significant. It scans incoming information for relevance, especially anything related to safety or uncertainty. When something stands out, this region influences the release of chemical messengers that prepare your body to respond. Your heart may beat a little faster. Your attention may narrow or widen. All of this happens gently, often before you are aware of it. Nearby, another set of structures helps link sensation with memory. When your body shifts, the brain quietly compares this change to past experiences. Have you felt this quickening before? Did it mean excitement, or did it signal caution? Memory does not speak in words here. It offers patterns. It suggests possibilities. In this way, your past becomes a subtle guide to your present. Higher up, along the brain's outer surface, networks integrate these signals into something more refined. These regions are involved in reflection, language, and prediction. They help you make sense of what is happening. If your pulse rises while you stand on a stage, your mind might interpret it as nervousness. And the same pulse rising while you greet a dear friend might become joy. The body's signal is similar, but the context reshapes the meaning. This is because emotions are constructed. They are assembled moment by moment from basic ingredients: sensation, memory, attention, and expectation. Your brain does not simply react to the world, it predicts it. Based on previous experience, it generates a model of what it expects to happen next. When reality matches that model, you feel steady. When it surprises you, emotion shifts. Imagine walking into a quiet room. You expect silence. If a loud sound suddenly breaks the air, your body startles. That surprise is not only about the sound itself, it is about the mismatch between prediction and reality. The brain updates its model, adjusting your internal state accordingly. This constant updating is part of how your inner weather changes throughout the day. The brain also works to conserve energy. It aims to keep your body in balance, maintaining stable temperature, blood sugar, and oxygen levels. Emotions help manage this balance. When you feel motivated, energy becomes available for action. When you feel calm, systems shift toward restoration. These changes are guided by networks that connect the brain to the body's internal organs, adjusting functions in subtle, coordinated ways. Within this system, chemical messengers act as gentle couriers. Substances released in response to certain patterns of activity influence mood and attention. Some promote alertness and readiness. Others support bonding and trust. These chemicals do not create emotion alone, but they shape the tone of your experience. They are part of the palette your brain uses to paint feeling. If you pause now and notice your breathing, you might sense how closely linked body and brain truly are. Slow breaths send signals of safety upward. The brain responds by reducing alertness in certain circuits, allowing muscles to soften. This feedback loop is continuous. The brain interprets the body, and the body responds to the brain in a quiet conversation that never stops. Attention also plays a powerful role. What you focus on becomes amplified in your emotional landscape. When your attention rests on a soothing sound or a gentle memory, neural activity aligns with calm. When attention locks onto uncertainty, different patterns emerge. This does not mean you control emotions with sheer will. It means that where awareness settles can influence how signals are interpreted. Importantly, no single brain region acts alone. Emotion arises from networks working together. Areas involved in sensation communicate with those responsible for memory. Regions that handle planning interact with those monitoring internal states. It is less like a command center issuing orders and more like a community of voices reaching agreement. This collaboration allows for nuance. You can feel bittersweet, a blend of warmth and longing. You can feel relief tinged with sadness. Such complexity reflects the brain's capacity to combine signals in layered ways. Emotional experience is rarely pure. It is textured, shaped by overlapping patterns of activity. Over time, repeated experiences strengthen certain pathways. If you often interpret racing thoughts as danger, those networks may activate more easily. If you practice noticing bodily sensations without judgment, different patterns may grow more accessible. The brain is adaptable. It changes with experience, subtly rewiring itself in response to how it is used. There is something reassuring in this flexibility. It means your emotional life is not fixed. It evolves. Even deeply ingrained patterns can soften when new experiences provide alternative interpretations. Safety, connection, and understanding can gradually reshape the brain's predictive models. As you rest here, listening, your brain is already predicting the rhythm of these words. The steadiness of the tone becomes expected. This predictability signals safety. Networks associated with vigilance can quiet slightly. Muscles loosen, thoughts slow. You do not need to force this process. It unfolds naturally when conditions allow. Sleep reminder here. If your eyes are heavy, let them remain closed. If your thoughts wander, let them drift like leaves on water. There is nothing to solve. The science can move gently through you, settling wherever it may. Your inner weather, then, is not imposed from outside. It is painted from within, using colors drawn from the body, the past, and the present moment. Each feeling is a fresh composition, shaped by countless subtle influences. And as we continue, we will look even more closely at how the body's signals rise upward, informing this delicate painting, and how sensation itself becomes the foundation for emotion. When you think of emotion, you might picture a thought, a memory, a quiet story forming in the mind. But before the story arrives, there is movement, a small shift in your chest, a warmth rising into your cheeks, a breath that deepens without asking permission. Emotion does not live only in the mind. It travels through muscle and skin, through pulse and posture, like a gentle current moving beneath the surface of a calm lake. Your heart is never simply beating. It is adjusting. With each moment, it responds to signals from the nervous system, subtly speeding or slowing, according to what your brain predicts you might need. When something captures your attention, electrical messages travel downward, nudging the heart to prepare. Blood flows more quickly to muscles. Oxygen delivery increases. Even if you remain still, your body is quietly readying itself. This readiness is guided by branches of the nervous system that balance one another. One branch mobilizes energy, preparing you for action. The other supports restoration, digestion, and calm. They are not enemies. They work together, shifting dominance like dancers taking turns leading. When you feel safe and at ease, restorative signals grow stronger. Your pulse steadies. Your breathing softens. Muscles release their hold. Our breath itself is part of this conversation. You are breathing now without effort. Yet your breathing pattern subtly changes with emotion. Surprise may cause a quick inhale. Relief may arrive as a slow exhale. These patterns are not random. Sensors in your lungs send information upward to the brain, confirming whether your internal state matches what is needed. The brain responds in return, adjusting rhythm and depth. Even the smallest muscles participate. The tiny fibers around your eyes tighten when you smile genuinely. The muscles in your shoulders rise slightly when uncertainty appears. These shifts are often so subtle you do not consciously notice them, yet they shape how you feel. Feedback from muscles travels back to the brain, reinforcing emotional states. A relaxed posture can gently signal safety. A clenched jaw can signal tension. Beneath your skin, networks of nerves constantly monitor temperature and touch. A cool breeze across your arm, the warmth of a blanket, the pressure of a mattress beneath you. These sensations influence emotional tone. Warmth often promotes feelings of comfort and connection. Physical contact can stimulate the release of chemical messengers associated with trust and bonding. The body registers safety through contact long before the mind names it. Deep within your chest, the rhythm of the heart contains subtle variations from beat to beat. These variations reflect how flexibly your nervous system is responding to the environment. When the system can adjust easily, you tend to feel more resilient, more capable of moving between states. This flexibility is a sign of balance, of the body's ability to meet the present moment without becoming stuck. Your stomach also participates in this dialogue. It contains a network of neurons that communicate directly with the brain. This connection explains why emotion can feel like a flutter, a tightening, or a heaviness in the abdomen. Signals travel both ways. Stress can alter digestion. Comfort can restore it. The so-called gut feeling is not mystical. It is communication along well-traveled pathways. Blood vessels near the surface of your skin expand or contract in response to emotional shifts. When you blush, vessels widen, allowing more blood to flow. When you feel sudden fear, vessels may constrict, conserving warmth and preparing for action. These changes are guided automatically. You do not instruct them. They unfold as part of the body's protective design. Hormones circulate quietly through your bloodstream, carrying messages from one region to another. Some increase alertness, sharpening perception. Others promote relaxation and bonding. These chemical messengers move more slowly than electrical signals, but their influence can last longer. They shape how long an emotional state lingers, how deeply it colors your perception. All of this occurs beneath awareness, like the steady hum of machinery in a well-tended garden. And yet, when you turn your attention gently inward, you can sense hints of it. The rise and fall of your chest, the steady pulse beneath your ribs, the warmth of your hands resting quietly. There is nothing you need to change. Simply noticing can soften the edges of tension. Research shows that bringing calm awareness to bodily sensation can influence emotional experience. When you observe a racing heart without immediate judgment, the brain receives updated information. The sensation is no longer interpreted solely as threat. It becomes data, neutral and manageable. This subtle shift can reduce intensity, allowing the nervous system to settle more quickly. The body also remembers. Repeated experiences of safety or stress shape how easily certain patterns activate. If you often encounter calm environments, restorative pathways become more accessible. If you experience prolonged strain, mobilizing pathways may activate more readily. Yet the system remains adaptable. Gentle, consistent experiences of safety can gradually rebalance it. As you lie here listening, your body is engaged in countless micro-adjustments. Your heart responds to the cadence of the voice. Your breathing synchronizes subtly with rhythm. This natural synchronization reflects how responsive your system is to external cues. Humans evolved to attune to one another. Tone, pace, and expression influence internal states without conscious effort. Sleep reminder here. If your breathing has slowed, allow it to remain slow. If your thoughts have softened, let them continue drifting. There is nothing to accomplish. Your body knows how to rest when given permission. Emotions, then, are not abstract clouds floating far above you. They are embodied currents flowing through tissue and blood. They tighten and release muscles. They warm and cool the skin. They shape the very rhythm of your heart. Understanding this does not require analysis. It invites appreciation. Your body is participating in every feeling, speaking gently in a language older than words. And as we continue, we will turn our attention to how these bodily signals sometimes arise even before thought. How feeling can precede explanation, and how the brain responds to these swift, silent messages before you are aware they have begun. There are moments when something shifts inside you before you can explain it. A slight tightening in your chest, a pause in your breath, a warmth that spreads across your face without warning. Words have not yet formed, and still the feeling is already there. This quiet speed is not accidental. It is part of an ancient design shaped long before language learned how to keep up. Deep within your brain, certain pathways are built for efficiency. When your senses detect a sudden change, a sharp sound, a fast movement, a change in expression on someone's face, signals travel along rapid routes that do not wait for careful analysis. These pathways allow your body to prepare before your conscious mind has time to compose a sentence about what is happening. This early response once meant survival. If a shadow moved quickly in tall grass, hesitation could be costly. The nervous system evolved to act first and explain later. Your heart might begin to race. Muscles may tense. Attention narrows automatically. Only afterward does the thinking part of your brain begin to interpret the situation, asking whether the shadow was a threat or simply wind bending the leaves. You can imagine this process as two overlapping waves. The first wave rises swiftly, carrying sensation and preparation. The second wave follows, slower and more deliberate, bringing reflection and meaning. Together, they create what you experience as emotion. The first wave is often subtle but powerful. It shapes the body before thought has a chance to intervene. Facial expressions are one of the fastest triggers of this early wave. Research shows that your brain can register emotional cues in another person's face in fractions of a second. Even before you consciously recognize a smile or a frown, deeper structures are already adjusting your internal state. This rapid perception supports connection and cooperation. It allows you to respond fluidly in social settings. Posture also shifts quickly. When you feel uncertain, your shoulders may draw inward. When confidence arises, your spine lengthens slightly. These changes happen with minimal instruction. They are guided by networks linking perception, emotion, and movement. The body becomes an immediate canvas for feeling. There is something reassuring in knowing that much of this process unfolds automatically. You do not need to command your nervous system to prepare for change. It is attentive on your behalf. At the same time, the thinking regions of your brain remain ready to reassess. Once more information becomes available, they can calm the initial response if it proves unnecessary. This partnership between rapid response and reflective thought creates flexibility. If a loud noise startles you, your body reacts instantly. But when you recognize it as a door closing rather than a threat, your heart rate settles. The slower systems gently override the initial surge. Balance returns. Intuition often arises from this interplay. When you sense that something feels right or wrong without being able to articulate why, your brain is drawing on patterns stored across years of experience. It is comparing present cues to past outcomes at remarkable speed. The result feels immediate, almost mysterious, yet it is grounded in accumulated learning. Memory contributes silently to this speed. Experiences leave traces in neural pathways. When similar situations appear, those pathways activate quickly, shaping your reaction. You may not consciously recall every past event, but the body remembers patterns. It responds according to what has been learned before. Hormonal signals also participate in early emotion. In response to perceived challenge, chemical messengers prepare your body within seconds. Blood flow shifts. Energy mobilizes. These changes occur long before conscious reasoning completes its assessment. This timing once gave humans an advantage in unpredictable environments. Yet, speed does not mean inevitability. The reflective parts of your brain remain active, capable of reinterpretation. When you pause and take a slow breath, you are engaging these slower networks. You are giving them time to review the situation, to determine whether the first wave of response still fits the present moment. Sleep reminder here. If your mind feels active, allow it to slow like a tide receding from shore. If your body holds tension, notice it gently without trying to force it away. There is nothing to fix. Awareness alone can begin to soften the edges. Interestingly, studies show that labeling a feeling in simple language can reduce its intensity. When you quietly name what you sense, even just to yourself, activity in certain regulatory regions increases, helping modulate deeper emotional circuits. Words do not erase feeling, but they can shape it, offering structure to the raw signal. Still, not every response requires analysis. Some emotions are brief adjustments, passing like quick gusts of wind. They rise, prepare, and settle without leaving lasting disturbance. Trusting this natural rhythm can reduce the urge to over-explain every flutter or shift. Your nervous system is designed for adaptation. It reacts swiftly, then recalibrates. It prepares for action, then restores balance. The feeling that arrives before thought is not a mistake. It is a protective echo from an earlier time, integrated seamlessly into your modern life. As you rest here, you might notice how the cadence of this narration reaches you before meaning fully forms, or the tone itself can influence your state. This is another example of feeling preceding explanation. The body responds to rhythm and sound long before the mind evaluates content. And so, emotions begin as swift currents, moving through you with quiet efficiency. Thought follows like a lantern, illuminating what has already begun. In our next gentle exploration, we will turn toward the softer emotions that arise when safety is certain. The warmth of joy and the subtle glow of contentment. And consider how the brain nurtures those brighter inner skies. Joy is often imagined as bright laughter, as celebration, as sound filling a room. But joy is also quieter than that. It can be the warmth that spreads gently through your chest when you notice something beautiful. It can be the small lift in your breathing when a familiar voice greets you. It can be the steady comfort of sitting somewhere safe, knowing nothing urgent is required of you. Joy is not always loud. Sometimes it is a soft glow, steady and sustaining. Inside your brain, this glow is shaped by networks that respond to reward and meaning. When you experience something beneficial, a kind interaction, a solved problem, a moment of connection, certain pathways become active. Chemical messengers are released that increase feelings of pleasure and motivation. These substances do not create happiness in isolation, but they enhance attention and reinforce behaviors that support well-being. One of these messengers plays a role in anticipation. It rises not only when you receive something rewarding, but when you expect it. This is why looking forward to a pleasant event can feel uplifting even before it happens. The brain is predicting a positive outcome, and that prediction shapes your internal state. Anticipation itself becomes part of the joy. Another set of chemicals supports bonding and trust. When you share a warm conversation or feel understood, these messengers strengthen the sense of connection. They calm stress responses and promote relaxation. Joy, in this form, is intertwined with belonging. It reminds your nervous system that you are not alone. There is also a quieter kind of happiness that emerges when the brain recognizes safety. In calm environments, restorative pathways become dominant. Heart rate steadies. Muscles soften. This state may not feel like excitement, but it carries a deep contentment. It is the satisfaction of balance rather than the thrill of novelty. Excitement and contentment are related, but distinct. Excitement often involves higher arousal. The heart beats faster. Energy rises. You may feel eager, alert, ready to move. Contentment, by contrast, carries lower arousal. The body rests in equilibrium. Breathing is smooth. Awareness feels expansive rather than focused. Both are forms of joy, shaped by different patterns of neural activity. Learning is closely connected to pleasure. When something leads to a positive outcome, the brain strengthens the pathways involved in that action. This reinforcement helps you remember what was beneficial. Over time, small moments of reward guide behavior gently, encouraging habits that support survival and connection. Even simple sensory experiences can trigger this glow. Warm sunlight on your skin, the taste of nourishing food, the sound of music that resonates with memory. These sensations activate reward circuits. They remind the brain that the environment contains sources of comfort. Attention lingers there a little longer, reinforcing the association. Interestingly, joy can broaden perception. Research suggests that positive emotional states expand the range of thoughts and actions you consider. When you feel safe and uplifted, creativity increases. You are more likely to notice possibilities, to explore gently rather than focus narrowly. This broadened awareness supports resilience over time. At the same time, joy does not erase difficulty. The brain can hold complex blends of feeling. You may experience gratitude alongside longing or calm alongside fatigue. Joy does not demand perfection. It can coexist with other emotions, offering balance rather than replacement. There is something deeply adaptive about this glow. It signals that conditions are favorable, that energy can be invested in growth rather than defense. In evolutionary terms, moments of safety allowed humans to build skills, strengthen relationships, and explore new environments. Joy reinforced these behaviors. As you listen, you might notice a subtle sense of ease simply from understanding this process. There is nothing extraordinary required to experience joy. It does not always arrive in grand gestures. It often rests in small, repeated experiences of safety and connection. Sleep reminder here. If your body feels heavier against the mattress, let it. If your breathing has found a steady rhythm, allow it to continue without interference. There is no need to chase happiness tonight. Simply resting is enough. Your brain also adapts to repeated exposure. When something pleasurable occurs frequently, its intensity may lessen. This process, sometimes called adaptation, it prevents overstimulation and keeps the nervous system balanced. Yet, even when the brightness fades slightly, the underlying sense of stability remains. Practices that gently draw attention to positive experiences can strengthen associated neural pathways. When you pause to savor a warm moment, you allow reward circuits to remain active a little longer. This does not force happiness. It simply gives the brain time to register safety and nourishment. The connection remains one of the strongest sources of joy. Shared laughter, mutual understanding, synchronized movement. These experiences align neural rhythms between people. Studies show that when individuals interact closely, their heart rates and breathing patterns can subtly synchronize. This alignment deepens the sense of belonging. Physical movement can also evoke positive emotion. Moderate activity stimulates the release of certain chemicals that elevate mood and reduce tension. The body and brain once again participate together, reinforcing the link between action and feeling. Even memory can rekindle joy. When you recall a positive experience, many of the same neural circuits become active as when it first occurred. The brain does not fully distinguish between present and vividly remembered reward. This is why reminiscing can bring warmth back into the body. As you rest here, consider how gentle joy feels in its calmest form. Not the burst of excitement, but the steady warmth of being at ease. Your nervous system recognizes safety in this quiet moment. Muscles loosen, thoughts soften. The glow is subtle yet real. In our next exploration, we will turn toward a different shade of inner weather. We will consider the gentle weight of sadness, not as a flaw, but as another adaptive current within the emotional landscape. One that slows and deepens perception in its own quiet way. Sadness does not usually arrive with noise. It settles. It lowers the volume of the world a little. Colors feel softer. Movements slow. Your body seems to draw inward, conserving energy. This gentle heaviness is not an error in the system. It is part of the same ancient design that once helped your ancestors survive. When something meaningful is lost or disrupted, your brain registers the change. Expectations that once guided your inner predictions no longer match reality. The nervous system adjusts. Energy that might have been directed outward shifts inward instead. Muscles relax slightly. Motivation decreases. Attention narrows. This slowing is not weakness. It is conservation. Deep within the brain, networks that monitor social connection and goal progress detect when something important has changed. When a bond is strained or a plan falls apart, certain chemical messengers decrease while others shift balance. The result is a drop in outward drive. The body conserves resources, redirecting them toward processing and recovery. You may notice that during sadness, your posture changes. Shoulders tilt forward, movements become smaller. This physical shift reduces stimulation and invites quiet. It signals to others that you are not in a state of threat or competition. In social groups, such signals once reduced conflict and encouraged support. Sadness can quietly invite care. Tears are another expression of this inward turn. The emotional tears contain slightly different chemical components than those produced by irritation. Their release may help regulate internal stress signals, though scientists continue to study the exact mechanisms. What is clear is that crying often brings a sense of relief afterward, as if pressure has been gently released. Breathing also shifts. It may deepen in slow waves, sometimes interrupted by subtle sighs. These sighs are not random. They help reset breathing patterns, restoring balance between oxygen and carbon dioxide in the blood. Even in sadness, the body is seeking equilibrium. Interestingly, sadness can sharpen certain kinds of thinking. Research suggests that when mood lowers moderately, attention to detail may increase. You may become more reflective, more cautious, more analytical. This inward focus once helped early humans reassess strategies after setbacks. It supported learning from mistakes and adjusting behavior for the future. At the same time, sadness reduces impulsive action. When energy is low, you are less likely to take unnecessary risks. This pause creates space. It allows the nervous system to recalibrate before moving forward again. In this way, sadness protects against overextension during vulnerable moments. Social connection remains central. Expressions of sadness often elicit empathy in others. Subtle changes in facial muscles and tone of voice communicate distress. These cues activate supportive responses in those around you. Humans evolved in groups where mutual care increased survival. Sadness became one of the signals that strengthened those bonds. Hormonal patterns shift during low mood. Levels of certain stimulating chemicals may decrease, while stress-related substances can rise briefly. Yet, over time, restorative systems work to bring the body back toward balance. Sleep patterns may change, appetite may fluctuate, but the system continuously seeks stability. There is also evidence that sadness deepens memory encoding. Events accompanied by strong emotion tend to be stored more vividly. This may serve an adaptive purpose, ensuring that important experiences are remembered clearly. Memory, in turn, informs future predictions, shaping how you respond to similar situations. Sleep reminder here. If a memory arises gently as you listen, allow it to drift without analysis. There is nothing to solve tonight. Your nervous system knows how to move through feeling at its own pace. Sadness often carries a sense of time stretching slightly. Moments feel slower. This temporal shift may reflect changes in attention and arousal. When stimulation decreases, perception of time can lengthen. The world feels quieter, less hurried. Though this can be uncomfortable, it also creates room for integration. Importantly, sadness is usually temporary. Like other emotions, it rises and falls. Prolonged low mood can signal deeper imbalance, but ordinary sadness follows a natural arc. It emerges, invites reflection, then gradually softens as new experiences reshape the brain's predictions. Compassion toward yourself during sadness can influence its course. When reflective regions of the brain engage in supportive self-talk, they help regulate deeper emotional circuits. Gentle understanding reduces additional stress layered on top of the original feeling. Now, you do not need to judge sadness for existing. It is part of being human. There is a quiet dignity in this emotion. It honors what mattered. It marks change as significant. Without sadness, joy would have less contrast. Without reflection, growth would stall. The same system that produces warmth and excitement also generates this softer gravity. As you rest now, you might sense how the body responds even to the idea of sadness. Perhaps there is a slight heaviness in the chest, or perhaps simply a calm neutrality. Whatever is present is allowed. The nervous system is always adjusting, always seeking balance. In evolutionary terms, sadness encouraged withdrawal when necessary, preventing further harm and allowing healing. In modern life, its purpose remains similar. It creates pause. It fosters insight. It signals to others that support may be needed. And as we continue our gentle exploration, we will turn toward another powerful current in the emotional landscape, one that sharpens awareness rather than softens it, one that prepares the body for protection with a spark of energy we know as fear. Fear often carries a reputation for discomfort, yet at its core, it is protection. It is a spark that briefly illuminates the edges of your awareness. When something uncertain appears, your senses sharpen, sounds feel clearer, movements become precise. The world narrows, not to trap you, but to help you focus. Long before cities and schedules, early humans relied on this rapid adjustment to survive. A sudden movement in tall grass, a shift in wind, an unfamiliar sound in the dark. These moments required swift preparation. The nervous system evolved pathways that detect potential threat quickly and efficiently. When activated, they send signals throughout the body, readying muscles and heightening attention. Deep within the brain, certain regions evaluate incoming sensory information for signs of danger. They operate with remarkable speed, often before conscious awareness fully forms. When uncertainty is detected, these structures communicate with the body through networks that influence heart rate, breathing, and muscle tension. The response is coordinated and purposeful. Your heart may begin to beat faster, sending more oxygen to tissues that might need to move. Blood flow shifts toward larger muscles. Pupils can widen slightly, allowing more light to enter the eyes. Even digestion slows temporarily, conserving energy for immediate demands. All of this unfolds within moments, guided by patterns shaped across evolutionary time. This response is sometimes called the fight or flight reaction, yet it includes more than movement. There is also stillness. In certain situations, the body becomes quiet and alert, conserving motion while gathering information. This pause can be as adaptive as action. It allows assessment before deciding the next step. Fear also sharpens memory. Experiences accompanied by strong arousal are often stored more vividly. This helps the brain recognize similar patterns in the future. Learning from threat once meant the difference between safety and harm. The nervous system refined its ability to remember what mattered. At the same time, fear is not inherently harmful. It becomes problematic only when it activates too frequently or without clear cause. In balanced circumstances, it rises when needed and settles when safety returns. The body is designed to shift back toward equilibrium once the situation resolves. Breathing changes quickly during fear. It may become faster or shallower, preparing for movement. Yet when you slow your breath intentionally, you send updated signals to the brain. The nervous system recalibrates, heart rate steadies, muscles begin to release. And this feedback loop demonstrates how body and brain communicate continuously. Interestingly, the same physiological signals that accompany fear can appear during excitement. A racing heart, heightened alertness, increased energy, these sensations are similar. Interpretation shapes the experience. Context determines whether the spark feels threatening or invigorating. The body provides energy, the mind assigns meaning. Fear also promotes caution. It narrows focus so that attention remains on what matters most in that moment. Peripheral concerns fade. This narrowing once allowed early humans to respond efficiently to immediate risk. Though modern threats differ from those of the past, the underlying system remains. Hormonal signals play a role in sustaining readiness. Certain substances released into the bloodstream increase alertness and mobilize glucose for quick energy. These changes are temporary. Once the brain perceives safety, levels gradually decline and restorative systems regain balance. Sleep reminder here. If the idea of fear feels activating, notice that you are safe in this moment. Feel the mattress supporting you. Let your breathing slow naturally. There is nothing in this room requiring defense. The protective spark can rest. Fear also contributes to social awareness. Humans read subtle cues in others' expressions and posture, detecting tension or threat. This sensitivity once helped groups coordinate responses. Shared vigilance increased survival. Even today, you may sense unease in a room before anyone speaks. Importantly, reflective brain regions can modulate fear responses. When you assess a situation calmly and determine that it is not dangerous, these regions send signals that quiet deeper circuits. Over time, repeated experiences of safety reshape predictive models, reducing unnecessary activation. Exposure to mild, manageable challenges can strengthen resilience. When the nervous system learns that it can recover after activation, confidence grows. The protective spark becomes less overwhelming and more informative. It remains available without dominating. Fear, in its balanced form, is guidance. It alerts you to boundaries. It encourages preparation. It signals when caution may be wise. Without it, survival would have been far less certain across human history. As you lie here, perhaps you can sense how your body responds even to this discussion. Maybe there is a subtle alertness. Maybe there is calm. Whatever arises is part of the same adaptive system. It adjusts continually, seeking harmony between vigilance and rest. In our next gentle exploration, we will turn toward another powerful current that mobilizes energy in a different way. The force that arises when boundaries are crossed and fairness feels disrupted. The emotion known as anger. And how it too carries a protective purpose within the landscape of feeling. Anger is often described as fire, yet beneath the heat there is structure. It does not appear without reason. It rises when something feels crossed, when a boundary seems ignored, when fairness tilts out of balance. Like fear, it mobilizes energy. But where fear pulls you away from danger, anger often pushes you forward toward protection or correction. In the body, anger begins as activation. Heart rate increases. Blood pressure rises slightly. Muscles tighten, especially in the jaw, hands, and shoulders. These changes are guided by the same mobilizing branch of the nervous system that prepares you for action. Energy becomes available quickly. The system is not aiming for destruction. It is preparing you to respond. Deep within the brain, networks involved in evaluating social meaning become active when something feels unjust. Humans are highly sensitive to fairness. Even young children show distress when resources are distributed unequally. This sensitivity reflects evolutionary pressures. Cooperative groups survive better than divided ones. Anger, in its adaptive form, helps maintain social balance. There is an important distinction between anger and aggression. Anger is an internal state, a signal. Aggression is behavior. The feeling itself does not demand harm. It simply communicates that something matters. Whether aggression follows depends on additional processes, including reflection, impulse control, and context. Regions in the frontal areas of the brain play a role in modulating anger. They evaluate consequences, consider alternatives, and apply learned rules. When these regulatory systems are engaged, anger can be expressed constructively. It can become assertiveness, boundary setting, or calm explanation rather than harm. Hormonal shifts accompany this state. Certain chemical messengers increase alertness and readiness. At the same time, stress-related substances may rise briefly. These changes heighten awareness and prepare the body for effort. Once the situation resolves, restorative systems work to bring balance back. Anger also narrows attention. You may focus intensely on the source of frustration. Peripheral concerns fade temporarily. This narrowing can be useful when clarity is needed, but it can also distort perception if sustained too long. The brain's predictive systems may amplify threat signals, reinforcing the emotional loop. Interestingly, expressing anger calmly can reduce physiological arousal more effectively than suppressing it entirely. When feelings are acknowledged and communicated safely, regulatory circuits engage. Heart rate decreases. Muscle tension softens. The body receives confirmation that the boundary has been addressed. Sleep reminder here. If you recall a moment of irritation, notice how distant it feels now. Your body is resting. Your heart is steady. There is nothing here requiring defense. Let your breath remain slow and easy. Anger can also signal unmet needs. It may arise when values feel violated or when expectations are disrupted. By paying attention to its message rather than only its intensity, you can uncover what matters most. This reflective process transforms raw activation into understanding. Physical movement often accompanies this emotion. You may feel the urge to stand taller or gesture more firmly. Muscles in the arms and chest engage. These shifts are part of the mobilizing response. When channeled through controlled movement, such as walking or deliberate breathing, energy can dissipate safely. Repeated exposure to chronic stress can sensitize anger pathways. When the nervous system remains on high alert, thresholds lower. Small triggers produce strong reactions. However, our consistent experiences of safety and fairness can gradually recalibrate these thresholds, strengthening regulatory circuits. Cultural norms shape how anger is expressed. Some environments encourage open discussion, others favor restraint. The brain adapts to these patterns, learning which expressions lead to resolution and which escalate conflict. Over time, habits form. There is also evidence that anger can enhance a sense of control. When faced with challenge, activation may counter feelings of helplessness. This shift in perceived agency can be motivating. It can support action aimed at restoring balance. Importantly, anger does not last indefinitely. Like other emotions, it rises and falls. Physiological arousal peaks and then declines, if not continually fueled by rumination. Allowing the initial wave to crest and settle can prevent escalation. Compassion toward yourself during anger can soften its edge. Recognizing that it signals something meaningful rather than something shameful reduces secondary stress. Regulatory regions of the brain engage more effectively when judgment decreases. As you rest here, you might sense how the body feels when calm. Shoulders loosen, hands rest easily. The energy that anger once mobilized is now quiet. This contrast reveals its temporary nature. Anger, in balanced form, protects boundaries. It reminds you of your values. It supports fairness within relationships and communities. Without it, injustice might pass unnoticed. With it, guided by reflection, change becomes possible. And as we continue our gentle exploration, we will move from this outwardly directed energy toward a different current entirely. The deep and binding force of attachment and love, where connection softens defenses and the nervous system finds rest in shared presence. From your very first days of life, connection shapes you. Before language, before clear memory, your nervous system learns through touch, voice, warmth. An infant's brain is not fully formed at birth. It develops in response to caregiving. When someone holds you, feeds you, responds to your cries, tiny neural pathways strengthen. These early bonds are not only emotional stories, they are biological architecture taking shape. Attachment begins as regulation. A newborn cannot steady its own heartbeat or temperature completely. Close contact with a caregiver helps synchronize breathing and pulse. Warm skin against skin stabilizes the infant's nervous system. In this way, connection becomes a source of physiological balance long before it becomes a conscious feeling. Deep in the brain, certain chemicals support bonding. When you experience closeness or trust, specific hormones are released that promote feelings of safety and warmth. These substances reduce stress signals and encourage relaxation. They make social contact rewarding, reinforcing behaviors that maintain relationships. Over time, repeated experiences of reliable care create internal models of safety. The brain learns that others can be trusted. This learning influences how easily you form bonds later in life. When early attachment is secure, stress responses tend to regulate more smoothly. When it is inconsistent, The nervous system may remain more vigilant, yet the brain remains adaptable, now capable of reshaping patterns through new experiences. Love in adulthood engages many of the same circuits that formed in infancy. When you feel close to someone, your brain activates reward pathways similar to those involved in pleasure. Anticipation of seeing a loved one can lift mood even before contact occurs. The expectation of connection itself becomes soothing. Physical touch continues to play a role. Gentle contact stimulates sensory nerves that send calming signals to the brain. Heart rate slows. Blood pressure may decrease slightly. Muscles soften. This is not imagination. It is measurable change in the body's internal balance. Eye contact also matters. When two people look at one another with warmth, subtle synchronization occurs. Brain activity patterns can align. Hormonal responses shift. These moments of shared attention strengthen social bonds. Humans evolved as cooperative beings, relying on one another for survival. The nervous system reflects this interdependence. Loneliness, by contrast, can activate stress circuits. When connection is absent, the brain interprets isolation as potential risk. Vigilance increases. Sleep may become lighter. Appetite may change. These responses once encouraged individuals to seek group re-entry. Connection is not merely pleasant, it is biologically significant. Sleep reminder here. If you feel the quiet presence of safety in this moment, allow it to deepen. Notice how your body rests more easily when there is no threat. The need for connection is part of being human, and right now, you are held in calm stillness. Love also influences pain perception. Studies show that supportive presence can reduce the intensity of discomfort. Seeing the face of someone trusted may decrease activity in certain pain-processing regions. The brain interprets closeness as protective, buffering stress signals. Shared experiences create shared memory. When you laugh with someone or face challenge together, neural pathways linking emotion and memory strengthen. These memories become anchors, reinforcing attachment over time. The bond grows not from grand gestures alone, but from repeated moments of mutual presence. Interestingly, giving support can be as regulating as receiving it. Acts of care activate reward circuits and promote feelings of meaning. Helping another person can lower stress markers and enhance mood. Now the nervous system recognizes cooperation as beneficial to group survival. Romantic love introduces additional layers of chemistry. Early attraction may involve heightened arousal and focused attention, driven by certain stimulating messengers. Over time, as bonds stabilize, calmer attachment hormones become more prominent. Passion may soften into steady companionship. Both phases reflect adaptive processes. Parental love carries its own patterns. Caregivers often experience strong protective instincts. Brain regions associated with vigilance and reward activate when they perceive their child. This dual activation supports both nurturing and protection, ensuring survival. Friendship, too, engages attachment systems. Though less intense than romantic or parental bonds, friendships provide emotional buffering. Shared humor, conversation, and mutual understanding contribute to psychological resilience. Humans thrive in networks, not isolation. The chemistry of connection does not remove all conflict. Disagreements arise even in close relationships, yet secure attachment provides a foundation for repair. When trust is present, stress responses diminish more quickly after tension. The body returns to balance with greater ease. As you rest now, perhaps recall someone who brings you comfort. Notice how even the thought of them may soften your breathing slightly. Memory alone can activate calming pathways. Now, the brain responds to imagined connection in ways similar to real interaction. Connection also shapes identity. Through relationships, you learn how others see you. Feedback from trusted people influences self-concept. The brain integrates social information into its predictive models, shaping how you interpret experiences. At a deeper level, love reflects mutual regulation. Two nervous systems interacting, influencing one another in subtle rhythms. Shared laughter, synchronized movement, gentle conversation. These experiences align internal states. Over time, such alignment fosters resilience. As we continue, we will explore how emotions travel between people, even without words, how moods can spread gently across groups, and how this invisible exchange of feeling weaves individuals into communities. If you have ever walked into a room and sensed its atmosphere before anyone spoke, you have experienced something subtle and deeply human. Feelings move quietly between people. They do not require language. A relaxed posture can soften a space. A tense expression can tighten it. Long before explanation arrives, your nervous system has already begun to respond. Humans are exquisitely sensitive to one another. Tiny muscles in the face shift in response to what you see in someone else's expression. Often this mirroring happens beneath awareness. When another person smiles gently, the muscles around your own eyes may respond in kind. This physical echo sends signals back to your brain, reinforcing a similar emotional tone within you. Deep in the brain, networks involved in perception and action overlap. When you observe someone reaching for a cup, regions associated with your own movement activate slightly. A similar overlap occurs with emotion. Observing another person's facial expression or posture can activate circuits related to that same state in you. This neural mirroring allows empathy to arise naturally. Your body participates in this exchange. Heart rate and breathing can subtly synchronize during close interaction. When two people share conversation or laughter, their rhythms may align without deliberate effort. This alignment is not mystical. It reflects the responsiveness of nervous systems attuned to one another. Even vocal tone carries emotional information. The cadence and pitch of speech influence how your brain interprets meaning. A slow, steady tone can calm. A sharp or rapid tone can alert. Long before you analyze the content of words, your body has already begun adjusting to their rhythm. This capacity for shared mood once strengthened group survival. In early human communities, rapid transmission of emotional cues allowed coordinated response to threat or opportunity. If one individual detected danger, their tensions signaled others to prepare. If safety was restored, relaxation spread through the group. So emotional contagion does not require dramatic events. Small shifts accumulate. A single person's calm presence can gently regulate others. Conversely, prolonged stress in a group can amplify individual anxiety. The nervous system is permeable in this way, shaped by social context. Interestingly, research suggests that empathy involves both automatic and reflective components. The automatic aspect arises quickly through mirroring and bodily response. The reflective aspect engages regions responsible for perspective taking and interpretation. Together, they allow you to feel with another person while still recognizing that their experience is distinct from your own. There is also evidence that positive emotions spread more readily when expressed openly. A genuine smile activates reward circuits not only in the person smiling, but also in those observing. This shared activation reinforces social bonds and encourages cooperation. A sleep reminder here. As you listen to this steady voice, notice how your breathing may have aligned with its rhythm. There is no effort required. Your nervous system simply responds to cues of calm. Let that alignment deepen if it wishes. Touch further enhances emotional transmission. A reassuring hand on the shoulder can lower stress markers. Physical contact stimulates sensory pathways that communicate safety. Even brief, appropriate touch can reduce physiological signs of anxiety. Digital communication introduces new patterns. Without full access to facial expression and tone, emotional cues may become ambiguous. The brain fills gaps based on expectation and past experience. This can sometimes amplify misunderstanding. It highlights how finely tuned humans are to subtle in-person signals. Shared rituals also synchronize emotion. Singing together, moving in coordinated patterns, or even sharing silence can align neural activity across individuals. These practices have existed across cultures for generations, reinforcing cohesion and belonging. Importantly, emotional contagion does not eliminate individuality. While you may sense another's mood, your own predictive models shape how strongly it influences you. Secure attachment and strong self-regulation can buffer against absorbing stress excessively. Compassion practices, for example, strengthen circuits associated with balanced empathy. They allow you to remain present with another's difficulty without becoming overwhelmed. The brain learns to differentiate between resonance and absorption. Children are especially sensitive to caregivers' emotional states. A parent's calm tone can soothe distress. Conversely, repeated exposure to high stress can heighten vigilance in developing brains. This sensitivity reflects the adaptive importance of social attunement. As you rest now, consider how even distant awareness of others can influence your state. A memory of shared laughter may warm you slightly. A recollection of conflict may tighten the chest. These echoes demonstrate how deeply social emotion is. Communities thrive when positive emotional signals circulate freely. Encouragement, gratitude, shared joy, these experiences build resilience. They create feedback loops that reinforce cooperation and trust. And yet, solitude has its own role. Time alone allows your nervous system to reset, to clarify which feelings are yours and which have been absorbed. Balance between connection and quiet supports emotional health. As we gently close this exploration of shared mood, notice how you are both separate and connected. Your feelings arise within your own body, yet they are shaped by countless interactions. In our next reflection, we will consider how emotions evolve across a lifetime, on changing tone and intensity as experience accumulates, and how age reshapes the inner weather you carry. Emotions do not remain fixed as you move through life. They shift in texture, in duration, in intensity. Like seasons passing across the same landscape, they reshape the inner world in subtle ways. A child's joy can be bright and immediate, rising like a sudden burst of sunlight. A child's sadness can be equally intense, yet often brief, dissolving quickly when attention moves elsewhere. The nervous system in early life is still learning how to regulate. Signals are strong and transitions are swift. In childhood, the brain's emotional circuits are active and responsive, while regulatory regions are still developing. This imbalance creates vivid feeling. Excitement may overflow into laughter or tears within moments. Fear may feel enormous, then fade just as quickly. These fluctuations are part of growth. Through repeated experiences of comfort and guidance, the brain gradually strengthens pathways that modulate intensity. As you enter adolescence, emotions often deepen and become more complex. Hormonal changes influence neural sensitivity. Social awareness expands. Peer relationships take on heightened importance. The brain becomes more attuned to social evaluation and belonging. Feelings during this period can feel amplified, not because they are irrational, but because the nervous system is recalibrating in response to new developmental demands. In adulthood, memory and meaning shape emotion more heavily. Experiences accumulate. The brain carries an archive of past joys and disappointments. When something occurs, it is filtered through years of learning. A simple event may carry layers of association. You feel not only the present moment, but echoes of similar moments before. Emotional responses become textured by history. At the same time, regulatory circuits in the frontal regions are more fully developed. These areas support reflection, impulse control, and perspective. They allow you to pause before reacting. They help reinterpret strong sensations. This does not eliminate emotion, but it can soften its edges. You may still feel anger or fear, yet you are more likely to integrate it with thought. Interestingly, research suggests that as people age further, emotional patterns often shift again. Many older adults report experiencing less frequent intense negative emotion. There is evidence that the brain gradually prioritizes emotionally meaningful information over trivial concerns. Attention may focus more on positive experiences. This phenomenon reflects both neurological change and shifts in perspective. With time, goals often adjust. In youth, there may be emphasis on exploration and achievement. Later, emphasis may shift toward connection and emotional satisfaction. The brain adapts accordingly, altering how it evaluates and responds to stimuli. Emotional regulation can improve as priorities become clearer. Physiological responses also evolve. The intensity of stress-related hormonal surges may decrease slightly with age. Recovery from emotional activation can become steadier. The nervous system learns patterns of resilience through repeated cycles of challenge and restoration. Sleep reminder here. As you reflect gently on your own timeline, there is nothing you need to analyze. Simply notice that your present emotional patterns are part of a long unfolding. Your nervous system has been adapting for years, quietly learning from every experience. Memory itself changes across the lifespan. Older adults often recall positive events more readily than negative ones. This may reflect adaptive processing, allowing emotional balance to stabilize. It does not mean sadness disappears, but it may become less overwhelming. Social networks also evolve. Relationships may narrow to those most meaningful. With this narrowing can come emotional clarity. Energy is directed toward bonds that matter most. The nervous system responds to quality over quantity. Yet at every age, the core biological systems remain. The same circuits that once responded to childhood fear still activate in adulthood. The same reward pathways that lit up during early friendship continue to support later companionship. Change does not erase origin. It refines it. Even now, as you lie here listening, you carry every previous version of yourself within your neural pathways. Early attachment patterns, adolescent discoveries, adult reflections, all contribute to how you interpret this moment. Your emotional landscape is layered, shaped by time. Importantly, growth continues. The brain retains plasticity across the lifespan. New experiences can reshape patterns, strengthen regulation, and deepen understanding. Emotional evolution does not end at a particular age. It remains dynamic. There is something comforting in this continuity. You are not defined by a single phase of feeling. You are a living system, adapting gently to changing circumstances. Intensity may rise and fall, but the capacity for connection and reflection persists. As we move toward our final exploration, we will consider how emotions, having evolved across time within you, can settle into harmony, not by disappearing, but by balancing with one another, on creating an inner stillness that feels less like control and more like quiet alignment. As the day moves toward evening, light does not disappear all at once. It softens, edges blur, colors grow warmer, then quieter. In much the same way as understanding deepens over a lifetime, emotions often begin to settle. They do not vanish. They do not cease their movement. But they feel less like storms and more like waves, rising, cresting, and returning to stillness without tearing through the landscape. Your nervous system learns from repetition. Each time you experience activation and then return to safety, circuits involved in regulation strengthen slightly. When you feel fear and then discover that you are safe, predictive models update. When you feel sadness and then experience comfort, the brain encodes that recovery is possible. Over years of such cycles, patterns of resilience take shape. Regulation is not suppression. It is coordination. Deep emotional circuits generate energy and signal importance. Reflective regions interpret, contextualize, and guide response. When these systems communicate effectively, emotion flows without overwhelming you. It becomes information rather than interruption. Inside the brain, pathways connecting emotional centers with frontal regulatory regions can strengthen through practice and experience. Gentle attention to bodily sensation, calm breathing, supportive conversation. These experiences activate integrative networks. Over time, they increase the speed and efficiency with which the system returns to equilibrium. Calm, then, is not an empty state. It is balanced activation. Your heart continues to beat. Your breath continues to rise and fall. Emotional signals still move through neural pathways, but they do so in proportion. They are neither exaggerated nor ignored. They are acknowledged and integrated. Safety plays a central role in this settling. When environments are predictable and supportive, the nervous system reduces its baseline vigilance. Stress hormones decrease more quickly after activation. Restorative systems regain influence sooner. The body trusts that balance will return. There is also a cognitive dimension. With accumulated experience, you recognize patterns more easily. You know that anger passes, that fear subsides, that sadness softens. This knowledge alters prediction. When the brain anticipates recovery, it does not escalate activation as intensely. Familiarity with your own cycles breeds steadiness. Sleep reminder here. If your thoughts feel slower now than they did at the beginning of this journey, notice that shift gently. There is nothing to hold on to. The rhythm of your breathing is enough. Compassion toward yourself and others further enhances regulation. Studies suggest that self-compassion activates caregiving circuits similar to those involved in nurturing others. These circuits reduce stress responses and promote soothing. When you meet emotion with kindness rather than criticism, you support internal balance. Mindful awareness also contributes. Observing sensations without immediate reaction engages regulatory networks. It creates a small space between signal and response. In that space, flexibility grows. Emotions are allowed to exist without dictating action. Importantly, harmony does not mean constant positivity. All emotional currents remain available. Fear still alerts. Anger still signals boundaries. Joy still glows. Sadness still deepens reflection. The difference lies in coordination. No single current dominates for long. As evening light settles across a landscape, shadows lengthen, yet they do not threaten. They simply coexist with fading brightness. Likewise, when emotional balance develops, darker feelings do not overwhelm. They become part of a larger, steadier field. Your body, too, reflects this harmony. Heart rate variability, the subtle fluctuation between beats, often increases when regulation improves. This variability indicates flexibility, the ability to adapt to change. It is a physiological signature of resilience. Social connection continues to support this balance. Supportive relationships reinforce safety signals, while shared calm strengthens regulatory pathways. Even solitary reflection, when grounded in a sense of security, can deepen steadiness. Over time, the brain integrates experience into narrative. You form a coherent story about who you are and how you respond. This coherence reduces uncertainty. The nervous system rests more easily when patterns feel understood. As you lie here now, perhaps you sense a quiet alignment within. Not the absence of feeling, but its gentle coordination. Breath steady, muscles soft, thoughts unhurried. This is not perfection. It is balance. And as this journey gently comes to a close, notice how wide and still the inner landscape feels. Emotions continue their movement, yet they do so within a spacious field of understanding. You do not need to hold every detail we have explored. They have already done their quiet work. If you choose to return again to these slow reflections, they will be here. But for now, there is nothing to decide and nowhere to go. Let your thoughts soften, your muscles relax, and the night carry you onward. Like evening light settling gently over calm water, preparing you for the quiet that follows. As this journey gently comes to a close, notice how wide and still the world feels. So many emotions unfolding quietly, whether we name them or not. You don't need to hold on to every detail. They have already done their quiet work. If you enjoy these slow explorations, you can support the channel in any small way that feels natural, so others can find this calm too. But right now, there is nothing to decide and nowhere to go. Let your thoughts soften, your muscles relax, and the night carry you onward, one peaceful breath at a time.